You know, there's this really pervasive myth in the tech world, the idea of the 10x developer or the rock star.
Oh, yeah. We've all heard that one.
Right. You picture this person typing at the speed of light, green text, scrolling down a black screen, inventing the next Google in a single caffeine-fueled weekend.
Mm.
It's romantic, but it's almost entirely fiction.
It really is. I mean, if you talk to the people who actually keep the internet running, the ones maintaining banking systems, cloud infrastructure, all that boring stuff that actually matters, they definitely don't call themselves wizards.
No, they don't. They usually pick a much more humble title, a blue-collar title, really. They call themselves plumbers.
Software plumbers, it's a great visual, honestly.
And that is exactly the kind of mindset we're exploring today. Welcome to today's deep dive. We're looking at a fascinating blog post from qianmeng.org. It's written by a developer named Ang, and it was published just recently on February 19th, 2026.
Yeah, and Ang actually explicitly introduces himself with that exact label, an old software plumber.
Which is so refreshing. But here is the kicker. The title of the post is Notes on Haskell Programming, Part 62.
Part 62.
Right. That number alone it stops me in my tracks.
It speaks volumes. Most people start a Learn to Code blog, write 3 posts about Hello World, and then just abandon it forever. Getting to Part 62 implies this level of grit that you rarely see.
Exactly. It's not about mastering the language overnight.
Right. It's about the grind, the slow process.
So our mission for this deep dive isn't just to look at Haskell syntax. We have this amazing source material, and we want to explore a very specific psychological transition that I think every learner goes through. It's that moment where you stop doing things just to make them work, and you start doing things so they actually belong.
Yes, that's the core concept of idiomatic programming. It's about the culture of the language. It's about respecting the tools you're using.
So we're going to unpack a specific refactoring journey. Ang is working on a Haskell program, and he decides to literally tear out a piece of code that, and I really want to stress this for you listener, was working perfectly fine.
Perfectly fine.
He tears it out to replace it with something more complex, more verbose, all in the name of being idiomatic.
And by the end of our deep dive today, you're going to understand exactly why that was the right call. We'll see that sometimes the hardest part isn't solving the logic puzzle. It's solving it in a way that fits the system.
Okay, let's set the stage. The program Ang is working on is a command line tool. It's called XS2 ebook. Based on that name, I'm assuming it's a converter of some sort.
Yeah, that's right. It basically takes an input file, maybe XML or some structured text, and converts it into an ebook format. Classic utility script.
And like any good tool you run from the terminal, it accepts arguments. You type the command, you provide the file path, but users are chaotic.
Always. You can never trust user input.
Right. If I accidentally feed this ebook converter a picture of my cat, a JPEG or an MP3, the program shouldn't try to convert it. It needs to realize, hey, this isn't text, and stop.
Exactly. You need a bouncer at the door. If you try to parse a binary image as text, the program will crash or output total garbage.
So Ang needs to check, is this a text file? Let's look at the before picture. The code he's ripping out. He had a validation check, and if the file wasn't text, he used a function called die.
System.exit.die. It's a standard function in Haskell. And honestly, in a lot of languages, PHP has die, Perl has die.
It sounds pretty dramatic.
It is dramatic. It does exactly what it says on the tin. It'll print your error message to the standard error output, and then it immediately kills the process, just pulls the power cord.
So the logic was literally check file, if bad, die.
Simple, effective, brutal.
But Ang calls this a manual implementation that terminates the program abruptly, and he decided it had to go. Now, play devil's advocate for a second. If I give the program a bad file, I want it to stop. So why is die considered dirty plumbing?
Well, it works if you're just running the script yourself. But think about the broader system. Think about composability. Die is a side effect. It doesn't return a value. It just destroys the universe of the program.
Okay, give me a concrete example of where that blows up.
Testing. That is the #1 headache here. Imagine you're writing a test suite, a separate program that runs your code to make sure it works. You write a test that says, I expect the program to fail if I give it a JPEG.
That seems like a standard test.
It is. But if your code calls die, it doesn't just fail the test case, it kills the entire test runner. Yeah. The testing program itself exits because your code committed suicide.
Oh, wow. Okay, so it's like testing the airbags in a car and the car explodes. You can't record the result because the recorder is gone.
Precisely. You wind up having to write these really weird, complex wrappers just to catch the exit signal. It becomes a huge mess.
And there's also an issue of consistency, right? Because he mentions the library he's using to parse arguments. It's called optparse-applicative.
Right. Very popular Haskell library. And it's polished. It has a specific way of formatting errors. It uses red text, specific indentation. It suggests things like, did you mean this flag?
It has a specific voice.
Yes, exactly. If Ang uses die, his error message looks completely different. Plain text, no color, weird formatting. To the user, it feels like two different programs glued together. It completely breaks the illusion of a cohesive tool.
So the goal of this refactor wasn't just fixing a bug. There wasn't a bug. The goal was to stop being a dictator who kills the process and start being a bureaucrat who files a proper report.
That is a surprisingly accurate analogy. He wants to integrate with the library's bureaucracy so his errors look official.
All right, let's get into the weeds. How does he actually do this? He introduces a new function called validate args. And immediately, looking at the source code, the syntax is, well, it's very Haskell.
It is distinctively Haskell.
The function header looks like an algebra equation. It says validate args at symbol, open parenthesis, args, curly brace, input path equals path. I mean, walk us through this.
This is one of those features that makes people's eyes glaze over at first, but it's incredibly powerful. It's a combination of record wildcards and an as pattern.
Okay, let's break that down for the listener. Start with the args part.
So args represents the entire data structure coming in. Think of it as a suitcase. He labels the whole suitcase args because he might need to refer to the entire thing later.
Okay, the suitcase is args.
But he knows that inside that suitcase, there's a specific document he needs right now, the input path. In a language like Java or Python, you'd take the suitcase into the function, and then on line 1, you'd say path equals args.inputPath.
You have to manually unzip it.
Right. Haskell says, why wait? In the function definition itself, literally at the door, he uses pattern matching. He says, I expect a suitcase that looks like args, and I want you to unzip it and hand me the input path as a variable called path right now.
So before the code even starts executing the main logic, the variables are extracted and ready.
Exactly. It's declarative. He's describing the shape of the data he expects to receive.
It's so efficient. It's like having a butler who hands you the specific file you need the moment you walk into your office instead of you having to dig through the filing cabinet yourself.
That's a great way to put it. And interestingly, Ang mentions in his post that this specific style feels familiar to him because of his background in Elixir.
Yes, I saw that note. He writes, this is similar to the approach I've been using in Elixir. I love seeing that kind of cross-pollination.
It's huge. We often think of programming languages as these isolated silos. You know, you're a Python dev or a Java dev. But a software plumber like Ang works across systems. Elixir is a functional language, famous for its pattern matching.
So he's taking a mental model from Elixir and realizing he can apply it in Haskell too.
Even though the syntax is different, the underlying thinking is the same. He stops writing if statements to check the data structure and starts writing patterns to accept the data.
But he does admit it takes time to adapt. He says, it took me a while to get used to this syntax.
Haskell is notoriously strict. It doesn't hold your hand. But he notes that by doing this, he localizes any changes. If he wants to add more validation later, he has a dedicated place, the function header, where all that unpacking happens.
Okay, so we've unpacked the data, we have the path. Now we actually need to check if it's a text file. How does he do that? He didn't just ask the file nicely.
No, he wrote a helper function called isText. And honestly, this is a fascinating little rabbit hole. How do you technically prove a file is text without reading the whole thing?
Yeah, if the file is a 5 GB video, you don't want to read the whole thing just to say no.
Exactly. So he uses a heuristic. He reads just the first 1024 bytes, the header, basically, and he checks for null characters.
Null characters.
Binary zeros, a byte with the value of 0. In standard text files like source code or novel, you almost never see a null byte. But in a JPEG or an executable file, they are absolutely full of null bytes.
Ah, so it's a quick sniff test. Do I smell binary?
Right. If he finds even one null byte in that first chunk, he returns false, not text.
Simple, low-level, and effective. But here is the critical pivot in the code. This is the truly idiomatic part. In the old version, if isText returned false, he called die. In the new version, he does something completely different.
This is the shift from imperative to functional programming. Imperative says, if bad, kill program. Functional says, if bad, return a data structure representing failure.
And to do this, he had to import a bunch of new bureaucratic forms. Looking at his imports, he brings in parser failure from options.applicative.extra. And he brings in error mementos and parser result.
It really does sound like paperwork.
It does. Why go through all this trouble just to say there's an error?
Because he's wrapping his error in a parser result. He's constructing a failure object that the library actually understands. He's filling out the official form. He says, okay, if the check fails, I'm going to return a failure container. Inside that container is a parser failure, and inside that is an error mementive.
And the message itself is the same, right? Error, path is not a valid text file, but now it's wrapped in 3 layers of library-specific bubble wrap.
Exactly. And because of that bubble wrap, the validation function no longer has to know how to print the error or how to exit the program. It just reports the news.
It completely decouples the logic from the side effect.
Yes. The function is now pure. You can run it safely in a test suite. It just hands you back a result, success or failure.
But eventually, the program does have to stop if there's an error. We can't just pass data packets around in a loop forever. Someone has to pull the trigger and exit.
And that leads us to the final piece of the puzzle, the parse-CLI function. This is where he wires it all together.
I'm looking at the code right now. The new line is validate args, then that weird symbol with the 2 greater than signs and an equal sign, then handle parse result.
The bind operator.
The monad stuff.
We don't need to get into category theory today, don't worry. Just think of that symbol as a pipe. It takes the output of the first thing and shoves it into the second thing.
Okay, so it takes the parse result from his validation and passes it into handle parse result.
The handle parse result is the magic box. This function comes directly from the library. It is the executioner. It opens the envelope.
And what does it do?
If it finds success, it unwraps the data and hands it to your program. Here you go, proceed. But if it finds failure, it takes over. It decides how to print the error message. It decides to color the text red. It decides to print the usage help text alongside the error. And it decides what exit code to use.
So Eng doesn't have to micromanage the exit process anymore at all.
No. He fired himself from the job of error handling and hired the library to do it for him.
And that brings us to the real payoff here. By using handle parse result, his custom validation error now looks exactly like every other error the library generates.
Uniformity. Consistency. That is the very definition of idiomatic. You can't tell where the library ends and Eng's code begins. It feels native.
That is so satisfying. It's like when you renovate an old house and you manage to match the original molding perfectly. It just feels correct.
But in software engineering, Eng is very honest about the cost of doing this.
Yeah, he writes a line that I really appreciated. He says, I'm currently unsure if the additional code complexity is the right path compared to a simpler method.
That is the eternal struggle of the programmer.
Right. He replaced one simple line of die with new import statements, new data types, and a monadic pipeline. Is this over-engineering?
It's the classic trade-off. For a tiny script that you only run once, maybe it is over-engineering. But Eng makes the argument that the value becomes evident as you add scale.
How so?
Well, imagine he needs to add 5 more checks tomorrow. Is the file too big? Is the file locked? Do we have right permissions? If he uses the die method, his code becomes a massive spaghetti mess of if, then die statements. It's hard to read, hard to refactor, and as we discussed, impossible to test.
But with the parser results approach.
He can compose them. He can chain validations together easily. The structure handles the complexity. It's the difference between patching a pipe with duct tape, because it's just a small leak, versus actually cutting the pipe and installing a proper valve.
The valve takes 10 times longer to install up front.
It does. But next time you need to shut off the water or add a branch to the pipe, you'll be thanking your past self that the valve is there.
There's another detail in his post that I found really modern and relevant for today's landscape. He mentions he refactored this with the help of AI.
Yes, that stood out to me too.
It paints a picture of the modern software plumber. He's not just sitting there flipping through a dusty manual. He's using AI to help translate his intent into idiomatic Haskell.
It's a fascinating workflow. Haskell has a famously steep learning curve. The documentation is often very academic. It tells you the types, but not always how to use them together in practical scenarios.
Right. Figuring out that you need a parser failure wrapped inside a parser result just by reading the docs is dry. Very dry.
Extremely. So using AI here acts as a bridge. He knew what he wanted. He knew he wanted to use the library's error type, but he didn't know the specific incantation. The AI acted as a pair programmer, who just happened to know the library better than he did.
It accelerates that journey from working code to belonging code. It helps you learn the culture of the language so much faster.
Exactly. It's not about the AI doing the work for you. It's about the AI helping you find the idiomatic path through the jungle.
Which brings us back to the source material itself. We've been focusing heavily on the code, but I want to zoom out to the old software plumber himself, Aang.
Oh, looking at the sidebar of kieranmang.org is a trip.
It's incredible. We're analyzing notes on Haskell Part 62, but right next to it in the sidebar are notes on fish keeping Part 200, notes on gardening Part 812, notes on guitar, notes on dieting.
This is a person who documents everything.
Notes on gardening Part 812. That implies years, maybe a full decade, of tracking and maintaining.
It connects perfectly to the theme of our deep dive today. Whether it's maintaining a fish tank, pruning a garden, or refactoring Haskell code, it's all the exact same mindset. It's about maintenance.
It's about the slow, steady process of improvement. You don't get to gardening Part 812 by rushing, and you don't get to Haskell Part 62 by just hacking things together and moving on to the next shiny object.
Precisely. The software plumber isn't chasing the new framework every week. They're revisiting a script they wrote on a Tuesday, and on Thursday deciding, you know what, this error handling could be cleaner. It's working, but it's not right.
It's almost meditative. It reframes maintenance from a chore into a craft.
And it teaches us that learning isn't just about absorbing new facts. It's about refining what you already have. Aang didn't add a single new feature to X2 ebook in this post. The program does exactly what it did before.
The end user won't even notice the difference unless they stare really hard at the error message formatting.
But internally, the system is healthier. It's more robust. And the developer is smarter. He now understands the parser result type. He has another tool in his belt for the next problem.
And it's cleaner. We started this by talking about how die was like a car crash. The new version is like a smooth stop at a red light. It communicates with the driver.
And that's the ultimate lesson here. Idiomatic code is about communication. It's communicating with the library authors who built optparse-applicative, respecting the types they created. And it's communicating with the future developer, maybe yourself in 6 months, who has to read this code and understand what's happening without tracing a bunch of abrupt exits.
So, to recap our deep dive today, we watched a software plumber take a look at a quick and dirty solution, the die command, and decide it just wasn't good enough.
We saw him use pattern matching to unpack his arguments early, a trick he picked up from Elixir, unpacking the suitcase at the door.
We saw him replace a program-killing action with a data-carrying result, the parser result.
And we saw him wire it all up using the library's native handlers, that handle parse result function, to create a standardized professional user experience.
And he did it all while maintaining over 800 notes on gardening, which honestly is the part I'm still most impressed by.
It's a lifestyle, really.
Yeah.
The philosophy of the long game.
So here is something for you to think about as you go back to your own work today. Aang refactored perfectly working code just to make it more correct for the future. He replaced the duct tape of system.exit with the proper plumbing of parser result.
It begs the question, what process in your life or your work is currently functioning but held together by duct tape?
It doesn't even have to be code. Is there a workflow, a script, or maybe even a habit that gets the job done but leaves a mess every time it fails? Maybe it's time to stop, look at it, and ask, how do I make this idiomatic? How do I make this fit the system properly?
Because sometimes the most productive thing you can do is fix the plumbing before the pipe springs a leak.
And maybe write a note about it. Call it part 1 of your new journey. Thanks for taking this deep dive with us. We'll see you on the next one.